So for part A, I need the power dissipated by the 6 ohm resistor. Power is always voltage times current. Now, if I'm looking for the power of a resistor, I can make the appropriate substitution with Ohm's law, and this can be written as V squared over R or I squared times R. These two equations are only for resistors. So we're looking for a power dissipated by a resistor. We're given the voltage, which is 12 volts, so it's probably easiest to use the equation that just has a voltage and a resistance. So in this particular case, I'll use power is equal to V squared over R, which is 12 squared over 6. And the power is equal to 24 watts. On part B, to find the voltage across the 3 ohm resistor, I'm given the current through the resistor, which is 1 amp. Plus minus voltage. Notice that I'm asked for a voltage, but I'm not given a sign convention. That means I get to choose my own sign convention. I'm going to choose my sign convention such that this current is entering the positive voltage terminal. Now, by Ohm's law, V is just equal to I times R, which is 1 amp times 3 ohms, which is equal to 3 volts. On part C, the current through the 4 ohm resistor, I'm given the voltage across the 4 ohm resistor, and I'm told that this is my positive terminal. If I define my current such that it enters the positive terminal, call this I4, then Ohm's law applies, and I4 is equal to voltage over resistance, which is 4 volts over 4 ohms, which is 1 amp. Now I could redefine my voltage polarity on this one and say that this is my positive terminal and that's my negative terminal, but then I have to change the sign on this. This would become a minus 4 volts with this being assumed higher than this. If I did this, then my current, I4, would be entering this one, this positive terminal here, so I4 would be equal to still V over R, which is minus 4 volts over 4 ohms, which is minus 1 amp. The difference between the positive and the negative sign just means that my arrow here has changed directions. I'm also not given a desired sign convention here, so either of these answers is correct as long as I indicate what direction I think is positive on my circuit.